This video will discuss on the second topic, namely project planning process for the system analysis and design course. This topic 2 exposes students on the planning phase, which is the first phase in the system development life cycles or SDLC. In this part 1 of topic 2, we will focus on the project initiation and feasibility studies. Let's move to the concept on feasibility study of the selected project. It is important to determine whether the selected project is suitable and feasible enough to be further developed. The objectives of proposed solution should highlight the improvement to the current issues faced by the organization. Feasibility study is performed to determine whether there are enough and available resources to start kick off the project. The resources cover the operational, technical, and economical aspects that give merit for the proposed project. Earlier, when we discussed on the problem definition content, one of the section is the objective. Objectives are the wishful criteria or the desired situation as an expectation to the improvement for the current process. Some clear objectives need to be defined are such as to speed up, to streamline, or to combine the existing process for the organization. The expected changes situation may also in terms of reducing the errors when the user key in the input, or to overcome the duplication issues of the generated outputs, to reduce the redundant usage of storage, or even maybe to improve the existing integration between current system and its subsystem. The proposed project is feasible when there are enough and available resources to start kick off for further system development. The resources cover three aspects. First, technical. Second, economical. And third, operational. A project must be feasible in all three aspects to merit further development. The proposed project is feasible in terms of operational when there are enough and available people or human resources to operate and use the system after installation in the organization. If users are satisfied with current situation, then the resistance to implement a new system will be strong and high chance of rejection. If users are dissatisfied, however, with the current system and they express a need for changes, then there are chances that the new system will be used. Therefore, the proposed project is operationally feasible. The proposed project is feasible in terms of technical if there are sufficient and supported technology for the new system. As for example, the selected project proposed the idea of transformation of dedicated database to the cloud-based database for better management and up-to-date storage to the company. In this situation, the technology is totally new and unavailable in the organization. Therefore, the organization should decide to agree or not to accept the add-ons of latest necessary technology for the proposed new system installation. In other proposal situation, for example, the company rejected the idea of using laser printer to replace the use of dot matrix printer in their daily business activities due to the cost factor. Meantime, they may be thought that the changes is not worthwhile because they assume they still can perform their jobs efficiently even with the old technology. The proposed project is feasible in terms of economical if there are sufficient money that can be spent upon time to merit further system development. Cost spent should be estimated and analyzed with the potential benefits bring to the organization. This is what we call as cost benefit analysis or CBA technique. The cost includes the purchase of new equipment and technology for hardware and software. In other words, the proposed project is not economical feasible if the short-term costs are not overshadowed by long-term gains or benefit, At the same time, the proposal does not have immediate reduction in operating costs. As mentioned earlier, cost-benefit analysis, or in short, CBA, is an analysis technique to calculate the spend cost estimation and compare to potential benefits bring to the organization. The CBA results may be referred to assist the organization in deciding whether it is worth investment and beneficial to develop the system as proposed. There are numbers of CBA techniques to estimate the IS development projection. For example, break-even analysis, payback, cash flow analysis, and present value analysis. The last one, present value analysis, or PVA, is a technique that will be used in this course to calculate the CBA. In addition to that, to estimate CBA, there are two main project costs that should be considered, that are development and production costs. The gain tangible and intangible benefit should be then compared with these two invested costs. It is known that the selected project must bring beneficial and improvements to the organization. There are two categories of benefits, that are tangible and intangible benefits. Tangible benefits can be estimated clearly when the proposed project save in terms of the cost or money invested, reduce number of human resources to be utilized, and shorten the spend time to perform the business activities. While the intangible benefits might be observed in terms of the improvement of employee behaviors or attitude, the increment level of staff productivity, as also receiving good feedbacks from the customer or external clients. There are two main project costs, that are development and production. Development costs is all the related money spent to the one-time installation of a new system. For example, the purchase of new hardware and software, the costs incurred during planning, analysis, design, and implementation phases. The production cost is the related budget spent to the operation of a system. For example, the cost of customer service supply, support, and maintenance, which incurred after the system installation. In this SECD 2613 System Analysis and Design Cost specifically, present value analysis, or in short PVA, will be discussed in detail and implemented as one of CBA technique for this topic too. PVA, compared with other CBA technique, is very much suitable to estimate the project cost and benefits if the payback duration or period is long. What is present value means? It is the value for money at present time or today compared with the same value in the future. For example, is the value of 10 ringgit Malaysia today in year 2020 is the same value of 10 ringgit Malaysia in late 1970s. And of course, the value of 10 ringgit in 1970s is higher than in current year 2020. It is because more things can be buy for 10 ringgit during that year of 1970s compared with present time. The formula to calculate the PV is as shown in the slide. PV N equal to payment times 1 power of N for 1 plus C. There are three important variables that you must understand: N, payment, and C, where payment is basically the amount of invested money. C is a discount rate. The term refers to the rate cost of money in investment and financial domain areas. The discount rate is normally decided by the company and it depends on specific industry in the country. And finally, small letter n represent the time duration to estimate the projection periods. Given the example as shown in the slide, the PV is 21,668 ringgit Malaysia for the project that spent amount of 28,840 ringgit for 3 years project duration with 10% discount rate. This slide and the following 2 slides show the example of how to calculate CBE for the given information on estimated costs, estimated benefits, and assumptions. Those assumptions such as discount rate, sensitivity factor, and annual change rate are normally have been decided and determined by the board of shareholders in an organization. Please take note that the listed estimated costs should be categorized as development costs and production costs. Hardware, software, consultant, and training criteria are all the development costs because these are the costs incurred at one time before new system is installed in client side or client organization. Supplies, IS support, and maintenance are all the production costs because these are the costs recurring during operation of a system. The CBA result using the PVA helps the system analyst to estimate whether the costs spent are worth and return some values of estimated benefits for a proposed project in certain period or duration time. In this slide, the table shows the CBA calculation for the estimated cost based on the given assumptions in the previous slide. In this example, we try to calculate the accumulated cost for 5 years project duration. First, the development cost is presented in year 0 column. Hardware, software, consultant, and training criteria are all the development costs. The estimated cost for each criteria should be then multiplied with sensitivity factor rate 1.1. For example, the asset value for hardware is 55,000. After 50,000 is multiplied with cost sensitivity factor rate 1.1. Second, the production cost for 5 years duration for an operational of installed system are presented in year 1 until year 5 columns. Supplies, network personnel, and maintenance are all the production costs. The estimated cost for each criteria should be multiplied then with sensitivity factor rate 1.1. For example, in year 1, the asset value for supplies is 2,640. After 2,400 is multiplied with cost sensitivity factor rate 1.1. Third, the following year 2 until year 5, the asset value for supplies should be then considered the cost annual change rate 7% or 0.07 in numeric. For example, in year 2, the asset value for supplies is 2,825 is the total from the 2,640 in year 1 value, and after 2,640 is multiplied with cost of annual change rate 7% or 0.07. Fourth, the present value or PV for all the annual production costs for 5 years should be calculated based on the previous PV formula that been explained. Lastly, calculate the accumulated cost from year 1 until year 5. For example, in year 1, 130,150 is the total accumulated cost after the present value 22,900 is added to 107,250 during year 0 of development costs. In year 2, 152,425 is the result of year 1 value, which is 130,150 is added to the present value of 22,275 of year 2. In this slide, the table shows the example of how we further calculate the estimated benefits, determine whether the projection show gain or loss, and calculate the profitability index. Step 6 is to calculate the accumulated benefit value for all 5 years of projection. Calculate the estimated cost for each criteria by multiplying it with sensitivity factor rate 0.9. For example, the asset value for inventory saving benefit is 70,200, where it is a value after 1,500 is multiplied with 52 weeks per year and multiplied again with cost sensitivity factor rate 0.9. In step 7, the following year 2 until year 5, the asset value for inventory saving benefit should be considered the cost annual change rate 5% or 0.05 in numeric. For example, in year 2, the asset value for inventory saving benefit is 73,710 is the total from the 70,200 of year 1 value, and after 70,200 is multiplied with cost of annual change rate 5% or 0.05. In step 8, calculate whether the project is gain or loss for each period of years. The formula for this step is accumulated benefit minus accumulated cost for each year. For example, in year 1, 66,332 in bracket shows the negative value that represent loss for this year 1. The value is the result of 63,818 accumulated benefit in year 1 is subtracted or minus with 130,150, which is the year 1 accumulated cost value. In step 9, the profitability index is calculated by dividing the year 5 gain or loss value, which is 75,697 with development cost, which is 107,250. If the profitability index value or PI is less than 1, the analysis results suggest that the proposed project with estimated costs and benefits is not a good investment for further development.